Hello students, so today we will start from where we left yesterday. So we will start with a new topic, new topic we can say, that is from our ratio of population population of atoms or molecules in two energy levels. Two energy levels. Okay, let me start with this. Yes, suppose let there are two energy levels, that is your level 1 and 2. Yes, let n1 be the population or number of atoms in energy level 1, and n2 is your number of atoms in energy level 2. Okay, so what will be the ratio? The ratio will the ratio, that is n2 upon n1, is equal to, let me darken more. Yes, n2 by n1 is equal to your, what is the formula for our population density or population? We can say exponential, that is energy, that is minus E2 upon your kBT. kB is the Boltzmann constant, it is the temperature. Okay, divided by exponential minus E1 upon kBT. Okay, is it clear to you? Yes. So what it will become? N2 upon N1 will be equal to exponential your minus E2 minus E1 upon kBT, isn't it? Yes. Make it a box in another color. Yes. Yes. We'll see about it later in our topic laser. Yes, we'll discuss about it in detail. Okay, so for now this is all about this. So let me proceed further and we will discuss a important chapter or important topic in details, that is our correction for nuclear motion. Correction for okay correction for nuclear motion. Yes, let me start. Yes, so first of all, in the development of Bohr's theory, the nucleus of atom was assumed to be stationary. So in Bohr's theory, in development of Bohr's theory, what we assumed in Bohr's theory, that the levels are stationary. Yes, okay. In fact, the motion of electron and nucleus under their mutual interaction is a two-body problem. If we consider the motion of electron around the nucleus, so it is a two-body problem. Two-body problem. Two-body problem. Okay, two-body problem motion. We consider the motion of electrons. Okay, in hydrogen atom, both the nucleus and the electron rotate with the same angular velocity. So in hydrogen atom, what happens? In hydrogen atom, both the nucleus and the electron rotate with same angular velocity. Okay, let's suppose, let omega about an axis passing through their center. So omega is the angular velocity, that is they rotate, the nucleus and the electron rotate about an axis passing through their center of mass. Okay, passing through their center of mass. I have taken the angular velocity as omega. Okay, and this axis is also perpendicular to the line joining them. Okay, is it clear to you? Yes, let's proceed further. We'll see in the diagram. Yes, let me draw the diagram for you, the two body problem diagram. Sorry, my hand my sketch is not that much good, you will have to adjust with it. Okay, let me try my best. Yes, okay, this is our perpendicular axis. Let me draw a perpendicular axis. Yes, where the center of mass lies, yes. So here is the electron. Let me suppose here is the electron, and this distance, this distance is r2 and this distance is r1. Okay, and here is, if I am considering the radius total is capital R, isn't it? Okay, yes. Let me write it for you, what I have drawn here. Let R be the distance between electron and nucleus, R1 and R2 be their distances from the center of mass, Okay, so I'll have to say that here is, yes, here is my nucleus and it is at a distance r2 from the center of mass. Okay, let mass of electron be small m and mass of nucleus be capital M. Okay, then we can say the moment of inertia I is equal to your m r1 square plus capital M into r2 square, isn't it? Give it equation number 1, and where r is equal to r1 plus r2, isn't it? Yes, give it another equation, that is equation number 2. Okay, and from principle of moment, we know m r1 is equal to capital M r2, isn't it? Give it equation number 3. So we can say that is m r1 minus r2 will be equal to capital M, that is r. Okay, let me erase it. This is only r. Yes, r minus r2 will be equal to m r2, capital M r2. Yes, and I can write it as, this is small m. Okay, you have to consider this is small m, so it will become m r1 will be equal to capital M into r2. this one, and I can write it as, okay, where is the erasure? Okay, I can write it as further into R2, isn't it? This one is R. Okay, I have done nothing but I just open the bracket and the multiplication happen here, and I have changed mr minus mr2 to the right hand side. Okay, and I got this. So what is my radius? That is r will be equal to radius, not it is a distance. Okay, r will become how much? Small m upon small m plus capital M into your r2, isn't it? Yes. Give it a box, give it a equation also, equation number 4. Okay, let me proceed further. Similarly, in the similar way, you can find that by substituting R2 will be equal to R minus R1. In the previous, I have substituted R1 is equal to R minus R2. In now, you can substitute R2 as R minus R1. So you can get from here R1 will be equal to capital M divided by small m plus capital M into R. Okay, do you get it? Yes, this is your equation number 5. Okay, now using this in our equation of moment of inertia, what we will get, I will be equal to the small m into capital M R upon small m plus capital M square plus capital M small m into R2 sorry R only, small m plus capital M square. Let me check this. Yes, yes, yes. Okay, we are good to go. Okay, okay, I have done a mistake here. It will become, you see here I have done, that is R2 will become your uh, m divided by small m plus capital M into R. Sorry for my mistake. Okay, let me go further. Yes, let me solve this for you. I will be equal to how much? Small m into capital M upon small m plus capital M into your R square, isn't it? So I can write this one as mu. Let this one, this value is mu into R square, where mu is equal to small m into capital M upon small m plus capital M. Okay, this is the reduced mass. We can call it as the reduced mass. We can call it as the reduced mass. Okay, yes. So let me define the reduced mass and what is its importance. Reduced mass, reduced mass. Let us talk about it. Mu is equal to small m capital M upon m plus capital M, isn't it? So 1 by mu will become 1 by small m plus 1 by capital M. Okay, the result shows that, what the result shows, the result shows that the result shows that the moment of inertia of electron nucleus system, electron and your nucleus system, electron nucleus system rotating about their center of masses, about their center of mass is the same as that of, is the same as that of, is the same as that of a fictitious body, of a fictitious body, that is a particle. Okay, it is similar, it is homologous to your effective body or a particle motion. Okay, thus the effect of taking the nuclear motion into consideration is equivalent to replacing electronic mass small m by reduced mass. Okay, so we replace the electronic mass, replace the electronic mass small m by reduced mass mu. Okay, isn't it? Yes, we replace small m by mu. Okay, in the reciprocal case, where 1 by mu is equal to 1 by small m plus 1 by capital M, and uh, when your, or we can say it is the special case, we can take the special case out of it, that is capital M tends to infinity, then what happens? Then mu will be tends to small m, and when small m tends to infinity, then mu will be equal to capital M, isn't it? Yes. Okay. Thus, the assumption that the nucleus is stationary is equivalent to assuming the nucleus to be infinitely large. Okay, so what's the conclusion when we are having from this discussion? That is, conclusion is very important. You have to just remember the conclusion, what we are getting by this experiment or by this expression. Okay, thus the assumption that nucleus is stationary is equivalent to assuming the nucleus to be infinitely large. Okay, large or heavy, you can say. Yes, do you get it? Yes, I hope you understood this. Okay, let us move further. Okay, so what are the result we will get by replacing small m by mu? By replacing, there will be change in your radius, energy, velocity. Okay, so let me derive those terms for you by replacing small m as your mu. Okay, let us do this. So first of all, we will see for radius what will be the changes in the radius expression. Okay, so Rn, that is capital M, will be equal to h square epsilon naught divided by pi mu e square and multiplied by n square upon z, isn't it? So by substituting your m as your mu, what we will get? Okay, let me write it for you. H square epsilon naught upon pi m e square n square upon z multiplied by small m capital M upon capital M, because we are considering the capital M case. Yes, so what it will become? Rn capital M will be become 1 plus small m upon capital M into your Rn infinite, isn't it? Yes. Let's make it a box. Let's give it a equation number 1. Okay, let me find out for velocity expression. Velocity. Okay, for velocity we have Vn capital M will be equal to E square upon 2h epsilon naught into Z upon n, isn't it? So Vnm will be equal to Vn infinite. Make it a box. This one is equation number 2. Let us derive the expression for your energy. Thirdly, we have energy. Okay. For energy, you have capital A and capital M will be equal to minus mu E4 upon 8 h square epsilon naught square into z square upon n square, isn't it? So what it will become? En capital M will be become minus m E4 8 h square epsilon naught square z square upon n square, your capital M upon small m plus capital M. Okay, so what it will become? En capital M will be become 1 by 1 plus small m upon capital M. Okay, these are the simple calculations. Okay, you can do by yourself. I am doing it for your experience or how you have to do it. Yes, let's make it a box. Okay, these are the relations. Okay, very important relations. Okay, yes, let me proceed further and find the Rydberg constant for you. Rydberg constant for you. Yes, so previously we have Rydberg constant value. Rydberg constant. So previously we have Rydberg constant as R infinite as 1.09737 into 10 to the power 7 meter inverse, isn't it? Okay, this one is for what? Infinitely. We are writing infinite because we are considering it for infinitely large nucleus. Infinitely large nucleus. Okay, do you get it? Yes. So let us do that for our new, that replacing M by capital M, what we will get from that. Yes, for hydrogen, let us consider hydrogen and derive it for hydrogen. For hydrogen, what we have, nuclear mass as capital M as nuclear mass for hydrogen, that is mass of proton is 1836 times Me, as you know, 1836 times Me. So RH will become how much? R infinite upon your 1 plus Me upon capital M H. So what it will become? R infinite upon 1 plus, that is capital MH, will be equal to 1836 times Me. So it will become Me upon 1836 times Me, isn't it? Yes. So further calculating, we will get RH will be equal to 1836 upon your 1837 into 1.09737 into 10 to the power 7 meter inverse. Okay, so it will become RH will be equal to your 1.09677 into 10 to the power 7 meter inverse. Okay, this is the Rydberg constant for H. Okay, for also for deuterium, tritium, you can calculate. I am only writing their values. Okay, only for deuterium For deuterium, you have Rd is equal to 1.09707 into 10 to the power 7 meter inverse. The order is same. 10 to the power 7 is always same. Okay. And for tritium, I have RT as 1.09717 into 10 to the power 7 meter inverse. Okay, you'll just have to memorize it. Okay, so now I have an important concept, that is positronium atom. Yes, let us talk about the positronium atom. Let me talk about the positronium atom. Okay, this lecture is going to be a long session because I am trying to cover it in small parts, but let me talk about this in details because as I have a little extra time for today. Yes, so let me talk about it. So positronium atom, what do we mean by this? When an electron and positron came together, they form a short lined atom, that is positronium atom. So let me write it for you. Okay, when an electron and positron came together, what happens? They form a short line, a short lived means its lifeline is so small, so we are calling it a short lived atom, that is the positronium atom. Okay, is it clear to you? In which both the electron and positron revolve about their center of masses. So in which both the electron and positron revolve around their center of masses. Yes, since both the particles have the same mass, both the particles have the same mass, that is mass m is equal to me, and capital M will be equal to mass of electron. Okay, so reduced mass will become, reduced mass, that is mu will be m into capital M upon m plus capital M, that will become me into me upon me plus me. So it will become me square upon 2me. So 2me, in denominator there is not square, only 2me there. Okay, so it will become me upon 2. Yes, so your reduced mass will become me upon 2 in case of positronium atom. Yes, and this one is the thing I want to derive for you. Okay, so we are good to go with it. And one more thing about the positronium atom, sometimes acts in your exam like CSR net, that is radius of positronium atom, that is Rn. Positronium will be equal to 2 into Rn of your hydrogen atom. Okay, so it will become 2 into 0.53 Armstrong, as I have derived earlier in my lecture. That will become 2 into this, so eventually it will become 1.06 Armstrong into n square, where n is the orbit number. Okay, remember this. So for now I am ending this lecture with this. So thank you for being with me and listen peacefully. Thank you for watching. So do like and subscribe my channel. Thank you for watching. Happy learnings. Okay.